Hi, Mark Papermaster. I'm CTO and EVP of Technology and Engineering at AMD.
And I'm Marshall Kirkpatrick. It's nice to meet you, Mark.
Good to meet you.
Mark, will you begin by telling us a little bit about the problem space? What problems do organizations face that bring them to confidential computing?
Well, more and more, trusted computing is just foundational because businesses rely completely now on the compute infrastructure they're putting together. Used to be that computing was on-prem. I'm going back years ago, it was all in your own premise. You could put whatever firewalls and protections around that. And then people learn more and more to be able to trust in the cloud. And that's why you see that the cloud business is booming. But we've really now reached a level where what people are running on the cloud and even on-prem, where you might be subject to insider threats, which are within those firewalls that you establish, you need additional protections. You need to have the utmost confidence that the jewels that you have of your business are protected. And with AI, that's even expanding because those jewels include all of the data that you're collecting on a day-to-day basis about your business that your competitors would love to have. It includes the trained models that you develop and you run your AI applications on. So the need for that type of additional compute confidence is simply growing at a very, very heavy clip, and AI is what's putting it on an inflection point right now.
Great. And what does success look like on the other end in terms of positive business outcomes you've seen or newly enabled technical capabilities with a successful implementation?
Well, success for us at AMD is we want it to be seamless. So we've designed our confidential compute implementation to be as easy as picking an option on a menu. We don't require code modification for your applications to run on AMD EPYC. And it's literally what we're striving to. We're partnering with cloud providers in doing this is that you really wouldn't see any difference in your performance or your application. If you want confidential computing, it's a click away.
Wonderful. And what's new? What's changing in your strategy?
Well, what's changing our strategy, I talked about AI as sort of it being the killer use case for confidential compute, giving all of the data and models and outcomes that you want to protect. And we've been focused on that. So new for us is with our 5th gen x86 server, which is EPYC, is our product name for those servers, and Turin is the code name of our 5th gen. And we are adding a capability that will expand that trusted window. So the CPU is at the middle. It's either your primary computation. You might, if you're running AI inferencing, you're probably also doing that on a CPU. That's the predominant, cloud-based inferencing engine today. But what about when you use an accelerator, like a GPU or an ASIC accelerator for AI? What about as you go to storage? What about as you go through the network? And so next for us is really having what we call trusted I/O. And we've been partnering with the industry on standards for trusted I/O. It's called TDISP, and that's the TEE, the Trusted Execution Engine with Device Interface Secure Protocol. It's a mouthful. That's why I call it Trusted I/O. And we're announcing today that it will be included in our 5th gen EPYC. So we're going to have TDISP capability. Those will be available later this fall. And so that trusted window of computing goes from that center CPU as it exists today CPU and memory, so data in motion or at rest on that CPU compute infrastructure. And now that whole sphere widens out to include true heterogeneous computing through the I/O endpoints.
Wonderful. How does a large ecosystem help drive the evolution of AI technology?
Well, we're all about ecosystem at AMD. We're huge supporters of open standards. We think about, even you talk about the TEE and getting to a root of trust. So how do you know that when you're talking to me, it's really me? We were a leader in starting a effort started with Microsoft and Google, and it became much broader across the industry called Calyptra, so that we could all have an open standard way in which we identify who we are as we talk to one another. And likewise, when I talk about trusted I/O, That has been done through the Confidential Compute Consortium with PCIe 6. The PCIe is an organization that's been around for I/O standards for years, and so that's also been a collaborative open standard effort. The other thing that we think is very, very important is transparency. And in fact, we've opened up our code, a lot of our code, to make it more transparent. And when you open up to the community, you again raise the bar of confidence, because the more eyes you have looking at your solution and making sure there's no cracks in the armor, the more confidence, more security that you have at the end of the day.
Big picture, medium to long term, where do you think confidential computing is going? How will it impact the world? And what do you think is especially important for the industry to keep in mind?
Well, I think, people always have a fear about their data. Is Big Brother watching me? Confidential computing means that your data is encrypted and you hold the keys. So it's a fundamental enabler of privacy. So it's privacy for corporations and that sacred data and models they have. It's also that privacy for individuals, with knowing that all of us over the course of the day, how much information on us is being collected at any moment. It's massive. And so I do believe that confidential computing will simply become pervasive, and that AI will be the application that drives its broad adoption. That's what the future is that we look back on this 5 years from now, and it won't be this unique boutique kind of capability. It's going to be everywhere. That would be my hope and my expectation.